Let's go.
Okay, so today the talk will be on Python debugging. And yeah, let me first start by talking about a brief history on the concept of debugging. So debugging was first coined by Thomas Edison. So he described in the 1800s a mechanical failure as a bug, which is honestly quite a weird word to use. Later on, in 1947, a bunch of Harvard professors were working on a computer where they realized that for some reason, whatever input they had, the output was consistently wrong. And when they opened up the internals of the machine, they realized that there was a literal bug inside the system. So the bug is actually right there. It's recorded over there. And that story has been popularized by Grace Hooper, one of the, I would say, forebearers of software engineering as we know it today. And so we have Thomas Edison and Grace Hooper to thank for this term bug, and therefore debugging. Okay, so let me start by answering the question, what is debugging? So debugging is the process of identifying and removing errors from computer hardware or software. But in the context of Python, typically you have a program and you expect it to work in a certain way, but for some reason it doesn't. And debugging is about finding out why doesn't it work, how it's supposed to work. And a debugger is a tool that helps you find out why that is so. So this is an illustration of a sample application. So any application you look at would always have some kind of input, and there will be some kind of output from the application. So it could be something like an API. You make a call to the API gives you some kind of response. Or it's some kind of application on your terminal. You give it some kind of input, you give it some kind of input, and then you get a response back. So that is the baseline of how any application works. And applications are built on functions. So at the top level, if you can imagine this as your default Python application, at the top level, you have your main.py. Your main.py probably imports other functions, and those functions imports other functions which relies on certain functions. So if you do look at any application, it is kind of a hierarchy of functions. And what it means to have a bug is that either one or more of these functions are not working as you would expect them to. And again, the goal of debugging is to find out amongst this tree of functions, which is the function that's misbehaving. So why do bugs occur in the first place? Typically, it's because of typos, logical errors, incorrect flows of executions, but mainly because of unexpected variable states. Again, an application takes in a state, returns a state. And within the processing, the reason why you have a bug is because within that application, the state is processed in an unexpected way, resulting in an unexpected result. So when it comes to debugging, the goal of debugging is to ask yourself these questions. First of all, what function caused a certain variable to change? What preconceived assumptions did you make about the functions that make up your code? What preconceived assumptions did you make about the state of your application? And lastly, how do you test and validate these assumptions? So again, when it comes to debugging, I would say in my career as a software engineer, bugs are not always obvious. And the reason why is because you will assume the application works in a certain way. You will assume that your function works in a certain way. But typically, it does not. And why you would think it works in a certain way is because, as I mentioned, there are certain assumptions that you make. And it is very important to test each of these assumptions. And I'll illustrate that later on in the presentation. Now, let me go straight into the examples of debugging an application. So I wrote an application for this presentation. Let me just quickly run through how the application works, and then run through the code. And then afterwards, I would run through the 3 ways of debugging. The 3 ways of debugging, first is print statements. Second is using the Python debugger. Third is using the debugger provided by VS Code. And I would and you can kind of see the difference between using each of these methods. So in order to run my application, and just as a quick summary of my application, it is a calculator. So it's quite simple. You just tell it, give it one number, give it another number. You mention which operator you want to use on both numbers, and then it gives you the result. And it loops again. So, oops. All right, so as you can see over here, thank you for using my app. Input, oh, I'm being cut off. Yeah. Let me see. I think I can.
Can you right click the sidebar and make it go away?
Sure. No right click. Oh wait, but it's here. That was weird. Okay. Let me see. So hi, thanks for using my calculator app. I could begin. So I input 1. Please select your mathematical operator. So I'll select addition. Please input my first number. Let me do 10. Please input your second number. Let me do 8. So 10 plus 8 is 18. And that is the result I get over here. And then the application loops again. It asks me again, would you like to select from one of the options? And I can exit by pressing 0. And there's also proper error handling. So if I were to input something silly, it would tell me that an invalid option has been entered. And I can, and it prompts me to select a correct option. So yeah, I can choose multiplication. 3 times 3 is 9. Okay. So now let's go to the code. So on top over here, we have the strings. These are constants, which is why it's all in caps. And then you have the enums, which elucidates the states which users have selected. After which you have the exceptions. So the exceptions are used to, again, elucidate the errors that that might occur within the application and proper error handling afterwards. And then finally, you have the functions over here. So all of this just gets input, returns input, selects the correct operation, so on and so forth. But of all of this, I think we would just be focusing on 2 particular functions, which is this one, get calculator result. So this one, this function would receive 3 inputs from users, mathematical operation, the first numerical constant, the second numerical constant, and then compute the result. And this over here, which is, well, where the heart of the code lives. Okay, so let's say I'm doing some basic debugging, and I want to know what is within menu input. So the most straightforward way, which most of us are probably familiar with doing, is you do a print statement like this. So over here, what will happen when this runs is these banners would print. You'll get prompted for an input, and after the input has been keyed in by the user, the state of menu input will be printed out. So I can very quickly illustrate that by going here. And okay, over there. So you see after input, there's menu selection begin. So it's quite clear that the state that variable holds is menu selection begin. Now the problem with this is it is difficult to see from all the lines that are being printed out, which one indicates the state of the application. So typically what I would do as a very quick shortcut would be to use banners. So this is a banner. It's simply just a print statement. It's simply just lines that wraps around the information which you want to present. So what will happen is this block will be printed, and it becomes very obvious when it comes to debugging. So let me quickly save this and restart the application. And yeah, you can see that there's a banner over here, the top banner and the bottom banner, and the information which you want to see within the application. Okay. Okay, so let's look at the get calculator result. When it comes to print statements, again, the goal is to examine the different states within your application. For example, this function over here, get calculator result, there are three things which determine the result of the calculator: the mathematical operation, the first numerical constant, and the second numerical constant. So what I could do in this function is simply do a print statement over here, which would print the result for me that I can see in my console. And let me just do this. So we have a nice banner. Let's do 10 plus 8 again. And you can see that here is the banner. We can see the mathematical operator is addition. 10 was the first input, 8 was the second input, and the answer is 18. And that's what's going on in the application. Okay, so now let me move on to using the Python debugger or using breakpoints. And I'll show why is it that they are slightly superior. So you see the problem about this, okay, no, I'll get to that later. So let me quickly, instead of printing, let me put a breakpoint over here. But let me first quickly go through what breakpoints are. So this was introduced in Python 3.7. You can just write this breakpoint anywhere. You do not need to import it directly. And what will happen is your application will stop at that particular point of execution. And from that point, you're given a Python interpreter, and you can do whatever you want. You could print environmental variables. You could examine the variables. You could change variables also within your application, which is quite helpful when it comes to debugging. So let me illustrate what I mean. So over here, with a breakpoint here, let me run the application again. As you can see, my application has now stopped at line 180 over here, since that is where my breakpoint is being placed. So 180, yep, breakpoint, so it's over here. And from this place, what I could do is I could also print menu input. So I could just do menu input, and yep, you can see that the value is being printed out over here. I could also do something like, okay, whatever is defined within this application, right? I have access to it. So whatever global variables, for example, I think over here, let's say in the display menu banner, I want to print it within the debugger. And remember, right now we're over here. So do display menu banner, and yep, it's being printed out. So it's nice because you get access to global variables and you get to see the state of your variables. So let me now exit the debugger by doing exit. Okay. And delete this. Okay. So remember this example which I talked about earlier on how you have to print these four variables. Using a debugger, all you need to do instead is to put a breakpoint right here, in fact. And then after that, you have access to the states of these things and you can print it out, which makes it more convenient, in my opinion. Okay. Another good thing about having a breakpoint is that it allows you to change the state of the application. So what I'm going to illustrate, right, is the same example as before. 10 plus 8, 18. And what I'm going to do is that I'm going to change the result of this function. So what would happen is that this function, instead of it returning 18, I'm going to make it return 19, which means that the result over here would be 19. So let me illustrate that. Let me see, breakpoint, correct place. Okay. So right now we are over here. And if we were to print the calculator result, the calculator result is 18. But I can change this result to 19 by simply doing an assignment. So calculator result equals to 19. And if I were to print the calculator result, it's 19. And if I were to exit the debugger, and if I want to continue executing, which is C, so that's a shortcut, you can see that the answer is 19. The state of the application has changed, which I think is useful if you want to force the state of the application, see if your functions are working how you intended to. Okay, so let me introduce you to more debugger features. So let's say that I'm over here and I use the debugger. So my application would stop at this point. And I would like to, and I don't really want to stop here. I want to go, I would like this line to execute. And then once I'm on this line, print the value within mathematical operation. Using the Python debugger, you can do that. So let me illustrate that. So over here, oh, hang on. I forgot to save. Okay, so right now we are on this line. Mathematical operation equals to get mathematical operation input, which is right here. So what I'll do next is that so the good thing about debugger is that it controls the flow of execution. Now I have complete control. And what I want to do is I just want to execute the next line and then print out what is within this mathematical operation variable. And how you do it is using the shortcut key N, which means next. And then I can select, and I'm back in the debugger. So right now we are at the next line over here, which means that this variable has been set, and I can just print the mathematical operator. Oh, oops. Mathematical operation. Yep, and it's over here. Now, the second good thing is I could step into this function. So for example, you see over here, get numerical constant. I would like to examine this function, step into it, instead of going into the next line. And how you do it using the debugger is with the shortcut key S. So okay, get numerical constant. Okay, there we are. So right now we are within the define get numerical constant function, which means that right now we are over here. And to show you that, go next. See, try. After that, numerical constant integer input prompt, which is exactly what you see on this line. So with the debugger, I can step into functions. Again, very helpful if I want to go into, remember I mentioned functions are like a hierarchy, like a tree. So it allows me to step within that tree and step out of the tree. Again, it is something that is invaluable to me when it comes to debugging applications. And let me see if that's it with regards to the debugger. Yeah, don't worry if all this is a bit complicated, because I can show you that for VS Code, it is much easier. You get a nice user interface. Okay, yeah, I think that's it with regards to the raw Python debugger. Yeah, this is definitely more performant and it's more portable. But I think for day-to-day activities, VS Code is something which I much prefer. Yeah. I see.
Have you ever tried the context command?
Sorry? Context? Oh, never.
Type context 10, context space 10. maybe it's a thing that only ipdb can do. Then you see 10 lines.
I see. Yeah, there are some.
But you know the L command?
L.
So this shows you more, right?
Okay.
When you only see one line, it's so hard to know where you are. When you press L, you can see the surrounding lines.
I see. Yeah, I guess I learned something new today as well. I see. Yeah, interesting. Okay, so let me quit this application. Okay, and let's go to the more user-friendly VS Code. Okay, so this again is the same. It's the same thing. It's the same application. And instead, what I'm going to do is that I'm going to run this on the Python debugger. And the way you do it is actually quite simple. All you need to do is just press F5 and that's it. Your application runs as if you're typing in Python main.py. So let me illustrate by doing that. And I say I want to run the current active Python file, which is the main.py. And you can see the application runs as if I was running it on the terminal. So I could do input. Oops. Yeah, breakpoint still there.
The word breakpoint.
Oh. Yeah, so you could also use breakpoint, I guess, to stop the application. Okay. Yeah. So it just works as per usual. Addition 10 plus 8 is 18 over here. So with this graphical user interface, what you can do is it makes it very easy to put breakpoints. Not sure if any of you have like hovered over the sidebar and see like these little red dots. These little red dots are breakpoints that you can dynamically put inside your application. So if I were to, for this get calculator result, I would like to put a breakpoint right here. All I need to do is just click. And you see this red dot indicates that there's a breakpoint that's on this line. So if I were to run my application on the debugger, and I were to use it as per normal, you can see that it stops right here. Okay. And the reason why I say it's a nicer experience is because you get this little toolbar up here. So this one will step over, which means that I want to go into the next line. Step into, which we have talked about previously, which is to go into the function, get mathematical operation input. So I don't want to do that. Currently, I'll just step over. So you can see it goes to the next line. Okay, requires an input. Oops. Yep, next line. Go to the next line, and then I'll be prompted to input my numerical constant over here. Yep. And another very nice thing about this VS Code setup is the debugger or the debugging tool would help to jump to the line where your function is being defined. So let's say over here, right now I want to jump, I would like to inspect the get numerical constant function. So what I'll do is to click step into, and you see that my screen jumps all the way on top. It goes into the function, and you can see visually how the function looks like, which is very useful, I guess. Okay. So that's it for the debugger. For those who are not really, okay, I'll say it. So far my talk has been geared towards kind of data science applications, not really for if you're trying to use Python to run a server, which is why I created an example on how to run the debugger on a server, which I will do right now. So for me, I use Fast API. And how you would set that up is you would mention, first you would go over here and click the run and debug tool. Next, you go to create JSON file. And over here, you're given some debug configurations that you can use. Just now we used the default Python file, but this time we're going to run a web server. And For the example that I created, I use Fast API. So all I need to do is just go here and click Fast API. And what will happen is VS Code would automatically generate a configuration file for me. And I need to make a few modifications because my server is running on this file called api.py, not main.py. So let me change this. And once that's done, if I were to run my application, as you can see, this indicates that this session is with the debugger, and my server is running on port 8000. Okay, and just to show you that it is running there, oops. Okay, over here. So yeah, my server is running. And just again to show that things are working, let me select 10 and 8. And if I do this, the result from this backend should be 18, exactly what we expected it to be. And as you would expect, it works exactly like how the VS Code debugger will work. So let me come over here and get calculator answer. If I were to put a debug over here and go back to my backend and send a request, there we go. It stops over here. And then you can start to slowly debug and start to check the states within the calculator request. Okay, one last thing, which is quite cool. So there's also conditional breakpoints you can set. So conditional breakpoints is simply if a certain condition is met, I would like you to break on this statement. There's no else, so you just go on if the condition is not met. So for calculator request, let me see. It takes in three things: first numerical constant, second numerical constant, and a mathematical operation. So what I want to do is I would like to do a conditional breakpoint. If the calculator request first numerical constant is 10, I would like the application to stop and give me a give me a Python interpreter and a debugger. Else, I would like the application to run as per normal. And how you do that is you right-click and you add a conditional breakpoint. So what will happen is calculator request dot first numerical constant, and the condition is I want it to be equals to 10, and only then will the application stop. So if I were to go to this application and change this to 9, the application runs as per normal. But if I were to change this to 10, it stops. And again, very useful in debugging, especially if you get unexpected data within your data set and you want to diagnose what is wrong. You can use this as a condition. Yeah. Okay. All right, let me quickly see if I've covered everything I wanted to cover.
Show the debug console.
Oh yes, the debug console. Sorry, I forgot to show that. So so think of a debug console as what you saw in the terminal, the PDB bracket, so on and so forth. The debug console is precisely that console. So let me do a breakpoint over here, no conditional, because we want to see what's going on. We will run this. Oh, weird. Okay. Okay. And for the debug console, you can well, you can just print whatever you want over there. So calculator, and you can see it's really nice because you can auto-complete over there. So I can select calculator request and let it auto-complete for me. And calculator request is it is a class, and the class contains these three things. So over here, there's nice autocomplete. If I put dot, it would show me the different things that different methods that I can access in the class and the different attributes that are within the class. So yeah, it's all here. And so I can do dot mathematical operation, and it would nicely autocomplete for me. Yeah. I think
you can also do assignments and change values.
Oh yes, you can. Oh, sorry, I forgot one more thing. Okay. Apologies, a bit messy. Okay. So I mentioned that one good thing about this is you get a nice graphical user interface. And the good thing about it Nope.
Start the debug session.
Yep. Okay. So over here, okay, let me. So one really cool thing is that you have access over here to all the global variables. It's all over here. You can see the constants that you define. You can see the functions that was defined in the application. And it's a really handy tool if you want to see what's really going on in the application. Unfortunately, the way I wrote this is that it is all in a single file. So I can't really illustrate the call stack. Because over here, what would happen is you can see exactly where the functions are being called within your application. And you can narrow down and inspect what's going on. And you know where to put the next breakpoint and the next breakpoint and the next breakpoint until you can hopefully find the bug. Okay. Let me go back to my slides. Almost done. Okay, so when it comes to debugging tools, you can see that for print statements, it is, I would say it's a very straightforward way of debugging because print statements is something which we're all familiar with. I hope for the most of you, your first Python application was print hello world. So we are all intimately familiar with how printing works. But with regards to Python Debugger and VS Code Debugger, I say that it takes a bit of effort to go out of the way to learn these tools, which is why in terms of ease of setup, ease of use is a bit more difficult. With regards to real-time insight, the problem about print statements is that your application has to run from start to finish, and whatever print statements you leave inside will be executed from start to finish. Your terminal might be flooded with messages, which is not very fun debugging. On the other hand, the Python Debugger and VS Code Debugger, you can stop execution at a given point of your code. You can step through, you can step in, you can step out, which is again very nice if you want to examine certain details within your code. And of course, the learning curve for Python Debugger and VS Code Debugger is high because, again, you need to go out of the way. But I think once you get over that hump, it is debugging becomes a much easier and a much enjoyable experience. Okay, but even though this talk was about the Python debugger, what I want to stress is that there are many ways of avoiding bugs within a program. And yeah, okay, so I created this diagram over here, which compares ease and effectiveness. And you can see debugging should be, oops, I didn't put debugging inside there. As using the Python debugger and the print statements. I don't know. So yeah, all of these are essential in preventing bugs from occurring within your program. So for example, let me quickly go through. So static analysis ensures that, assuming that you type your code, that your code is syntactically correct. That if a function states that it returns a number, it returns a number. If it returns a string, it returns a string. And your editor can jump in and say, you're doing something wrong. Please correct this. And that's very helpful in diagnosing data-related bugs. Yeah. Python, by right, it can't do that, but there's a typing module that you can use. Yeah, they're not. So yeah, you're correct about that. Types are suggestions. Your editor will scream at you, but then your program would still run as per normal. Yeah. Wait, in the case, I might be confusing static analysis and type validation. Yeah, thinking about it. Yeah. Oops. I see. Yeah, I should make some changes to that then. Of course, let me see. On the other hand, you have refactoring, code reviews, documentation. So it's important that that your code is being regularly read and it's able to be understood by other people. And that's the reason why we have code reviews. Documentation ensures that, well, if people understand, if there's clear documentation, it hopefully means that people understand what your code is trying to do. And when it comes to debugging, they can use that as a template and apply it to whatever they're trying to debug. And of course, lastly, we have testing and clean code. So testing ensures that your function performs the way it's supposed to perform. And clean code, this ensures that your function is readable and your program is broken down into, your program is as modular as possible. So that when it comes to debugging, you don't have to look at one function, you look at many functions that all support the same thing. Yeah, I think with that, that's the end of my presentation.